Good morning. Anmol Classes welcomes you. In this video, we'll be seeing your Data Science Lab experiment number 8. Your 8th experiment is built using K-mean algorithm. So here, clustering algorithm for unsupervised classification and plot the cluster data using R visualization. So in your this 8th experiment, the data set that we are using the iris data set. So now let us see your overall workflow. So first you need to load the data set, then you need to select the features for clustering, standardizing the data, applying K-mean clustering, add cluster labels, compare clusters with actual species, and then you are having 3 visualization. One visualization is for basic scatter plot, second one is using a ggplot2, and third one is your professional cluster plot. So as we are going for 3 different visualization, here instead of going for your R console, we will be preferring your RStudio. RStudio is a preferred one. Say suppose we can use R console generally for one visualization. Here you are having 3 different visualizations, so it is better to use your RStudio. So from here your program is starting. So directly we'll be seeing the program and your expected output. So here first you need to load the data set. Here we are using the iris data set. As you are knowing, the iris data set, you are having 150 flowers, and in that you are having 5 attributes. The 5 attributes you are having sepal length, sepal width, petal width, and species. So here in your iris data set you are having 3 different species. Okay, so as here the species is a category, we will reduce this 5th column. So view first few records. We'll be going for head iris. So when we are going for your head iris, you will be seeing first 6 observations. So head display first 6 rows, and the purpose is to understand the data structure. It verifies the data is loaded correctly or not. Since clustering is unsupervised, we don't use the species column. So as you are knowing that here we are having 5 different attributes, but we'll be using only 4 attributes. So select the numerical features only. So iris data less than dash iris comma 1:4. So here in your iris data set we are using all rows, and when we are going for column we are using column 1 to column 4. Okay, and we are excluding your column 5. Column 5 it is your species 1. So explanation, K-mean works only with the numerical data. Here you are seeing the 5th column, that is the species, the name of the species, it is not in a numerical. So we select sepal length, sepal width, petal length, and will exclude the species because it is a categorical. It is not a numerical. Then we need to go for check structure. For checking the structure, we are having structure iris data. STR shows the data type, number of rows, number of columns. So here you are having 150 observation, and you will be having 4 variables. As the 5th variable we have already excluded, so we are having 150 observations of 4 numeric variables only. Then you see, say suppose if we are executing in R console, you will be getting the output something like this. So first you are having loading your iris data set. When you are going for head iris, first 6 you will be seeing. Then you are going for selecting all the rows and only 4 columns, then you are going for seeing the structure of that one. So here you see 150 observations of 4 variables, that is your sepal length, sepal width, petal length and petal width. Only these 4 are numeric, so we will be using these 4 only. Then standardizing is recommended because variables have different scales. We need to go for normalizing the data. Normalizing the data means, say suppose if you are having the different attributes and the different attributes are having, say suppose some length is in terms of millimeter and some length is in terms of centimeter. Okay, so we cannot justify. Say suppose if you are having a 20 millimeter and you are having a 3 centimeter. So though 20 is numerically more than 3, but 20 millimeter is not more than 3 centimeter. So there is a need to normalizing the data. So for that we are going for your iris scale less than dash scale iris data. So it is telling that why normalizing. So variables have different range. Example, say sepal length, its range is 4 to 8, and petal width, its range is your 0.1 to 2.5. So without scaling, larger values dominate clustering. So we will be seeing the formula for your standardization. So when we are going for your standardization, here you are having a z is equal to x minus mu by sigma. X is your original value, mu is your mean, and sigma is your standard deviation. Then view normalized data. Head iris scale. So sample output you will be having, say sepal length and sepal width. This is the sample output. It is the normalized one. Meaning is values are converted into standard score, that is your z score. Now we need to choose k is equal to 3. Why we need to go for selecting k is equal to 3? We need to go for selecting k is equal to 3 as we are having 3 different species, because the iris dataset contain 3 species. Okay, set seed for reproducibility. Set seed 1 to 3. Explanation: K means starts with a random centroid. Using a seed, set seed 1 to 3 ensures same random values, same clustering result every run. This improve reproducibility. Apply k-mean clustering. K-means model less than dash, k-mean iris scale, center is equal to 3, n start is equal to 25. So center is equal to 3. We want 3 clusters because iris dataset contained 3 different your setosa, versicolor and virginica. So you are having 3 different species for your iris dataset, and n start is equal to 25. K-means tried 25 different initial centroids and selects the best solution. How k-means work? So if we want to see that how k-means work, so we need to choose the initial centroid. Let us assume that you are having C1, C2 and C3 are your initial centroid. Then we will calculate the distance from every point to every centroid. So you are having the distance formula. Distance formula is your square root of x2 minus x1 whole square plus y2 minus y1 whole square. Then we need to assign point to nearest cluster, compute new centroid and repeat until centroid stops changing. So this in R console, if you are executing it, you will be seeing like this. Then we need to go for display cluster information. K means model. So output will contain the cluster size, cluster mean, within cluster sum of squares. Example, K-mean clustering with 3 clusters. Then we need to go for add cluster labels to dataset. So iris $ cluster less than dash as a factor. K means model dollar cluster, means cluster number you can have 1, 2, 3 are added to dataset. So in your iris dataset you are having 3 clusters only. So here you see for clustering vector, So for clustering vector, you are having all these values. So then we can go for view result. So you are having a head iris. So example, sepal length, if it is 5.1, species Setosa, and cluster is 1. Then we can go for your confusion table. Confusion table, it is your confusion matrix. So you are having table iris species, comma iris cluster. Okay, so it creates a confusion matrix. Example, here we are having cluster. So cluster 1, 2, 3, and here we are having the species. You are having Setosa, you are having varicolor, and you are having Virginica. 3 species you are having. And then if you are seeing your this confusion matrix, what is your interpretation? Your interpretation is that your Setosa, it is there, it is confined to only one cluster. If you are seeing your versicolor, it is in your cluster 2 and in your cluster 3. So in cluster 2 you are having 39 element, and in cluster 3 you are having 11 element. Virginica, here you are having in cluster 2 you are having 14 observation, and in cluster 3 you are having 36 observation. This means that your Setosa is confined to your only one cluster, whereas your versicolor and Virginica, there you are having overlapping in cluster 2 and cluster 3. This is your interpretation. So Setosa, it is perfectly clustered. Some overlapping between your versicolor and Virginica you have observed. Okay, then we can go for your scatter plot. So when you are going for your scatter plot, plot iris $, sepal length, iris $, sepal width, color K-mean model $cluster, PCH is 19, X label is your sepal length, Y label is your sepal width, mean is your K-mean clustering. So your heading is K-mean clustering. In X-axis you are having sepal length, in Y-axis you are having a sepal width. And pitch. Pitch means, so here you will be having the solid circle. Here you will be having the solid circle. So that is your 19 it is telling. So color means your model cluster, and result you will be having the colored cluster display. Now we'll try to run this program in your R console, and then we will represent the same thing in your R studio.